In this video, we're going to talk about plane figures, which really is kind of a way of saying that we're going to do some introduction to geometry. Okay, so geometry, I hope most of us are familiar with that. Most people think it's like a visual version of mathematics, and that's true. It actually comes from the Latin word geometria, which basically means earth measure. So it's the way we measure our world. Okay, there are a lot of definitions in this section. So be prepared. We're going to be defining a lot of words, and in many times we'll be drawing a lot of pictures too, since we are looking at earth measure. Okay, so the first definition is axiom. Now, an axiom is something that's kind of so self-evident you can't prove it. Okay, so I'm going to say it this way: something that is so evident or so evidently true. That's how I worded it. So evidently true, it can't be proven. And I mean, some of these, if you go ahead and look up like Euclid's axioms, there's a bunch of them that are truly obvious, and then a bunch of them that aren't very obvious. But unfortunately, you have to accept them as true, and it is true when you think about it. but but yeah, they're not proven. Okay, things that are proven, those are called theorems. Now, when theorems are written, sometimes they have little like almost like mini theorems, lemmas, corollaries. There are other words. We're not going to get too much into that. A lot of people, if they've taken geometry in high school, they did proofs of theorems. They weren't real proofs. They were kind of like a basic outline proof to help start students off understanding the idea behind proofs and theorems. But there you go. Okay, so we're going to kind of start with the most basic things in figures. And the first thing we're going to look at is a point. Now, if I asked you to define a point, like I'm like, come up with a definition of a point, and I'd encourage you, like, come up with a definition of a point. It's actually kind of hard to describe, really. So the definition we're going to use is a point has no length, width, or thickness, and it models an exact location in space. Oops. And when you think about it, I mean, that makes sense. When you think of a point, right? So here, I'm going to draw a point. Ooh, so exciting. There's a point. Okay. And the point is you might have thought of like how we label points on an XY plane, right? And we have like an ordered pair assigned to it. Um, I actually encourage everybody to kind of think about, okay, so what's an example in real life on the earth, right, of a point? And when I do this, I typically think, okay, like in your room, where is a point in your room? Okay. Now, because it's not supposed to have length, width, or thickness, you can't really think of an object necessarily as a point. It's more of like a concept. So when I look around my room, I'm going to give this as an example. The corner where the ceiling, oh, sorry, that's not how you spell where, where the ceiling and walls, oops, and two walls meet. So that corner represents a point. That single location in the room, okay, has neither thickness, width, or length, but it is identifiable and is a conceptual place in the room that has a location. Okay, so that is a point. All right, the next one is a line. And again, I encourage you, think of a definition of a line, all right? Or think about where a line would be in your room, okay? A line also, a line has no thickness or width. So similar to a point, it has no thickness or width, but it does have length, okay? But it describes, oops, wow, that's not how you spell the word but it describes a straight object often between 2 points. Doesn't have to be between 2 points, because in theory, a line can go on forever, okay? But on planet Earth, typically when we see lines, they have an end, okay? So for us, looking around my room, an example of a line would be the edge where the ceiling and a wall meet. All right. So that's the kind of generalized definition I'll use for a line. Now, before we move on to the next object, there is kind of a lot having to do with lines that in terms of like notation and even drawings. So I mentioned that a line can in fact go on forever. When we draw something like that, we would put arrows on the end. And if I wanted to be able to label this, there's a few ways I could do that. One is just to put like a letter next to it and say, okay, that's the line L. They like to use the cursive L often, or an italicized L, which I can't do on my writing. So I use a cursive L. But yeah, that could represent the line. Another way of representing a line would be to actually put some points on the line with labels. Okay. And because we're going to be exploring geometry, this type of notation, we would say this is the line AB. So in writing, this is how I would write that visualization. Okay, this would be the notation I would use. Okay, now if the line is actually a line segment, that means it doesn't go on forever and it stops between points A and point B. So this is a line. This is a line segment. And that notation we use, it doesn't have the arrows above it. So the arrows actually are indicating that it's going on forever, where this is indicating there's a start and a stop. Okay. When there's only one start and stop, start or stop, I should say, but the other one actually has an arrow, that's called a ray. And when you draw the notation, it's actually important that the starting point is the one that is the quote unquote end point. And we put the arrow over the B because it goes through B. So it keeps going on. So if I had happened to have a ray going the other way, so like here's A and B, same order, but it's going like this. When I write that notation, I want to actually write it where the B starts and then A. Okay, that's how you'd kind of want to write that. And of course, I could have drawn it backwards too, right? Like the picture above, but swapping the B and the A. But that's the idea. If I see something like this, the notation I'm going to use, excuse me, is going to indicate that the A is the direction where it's going on forever. Okay, the next vocabulary word is plane. Now, a plane is actually two-dimensional, okay? But we often see it in 3D. So a lot of people kind of try to think of it as a third-dimensional object, but it actually isn't. It is a two-dimensional object. So a plane is a flat two-dimensional object or surface. Sorry, here, let me use that word, surface. Read your words, Allison. Surface that extends to infinity. And because it's two-dimensional, it has length and width, but no thickness still. So, and has length and width, but no thickness. Or another word would be depth. Okay. All right, so there you go. Those are kind of the basics of the figures that we're kind of build our whole earth space on. All right. So looking around my room, finding an example, well, the wall or the ceiling or the floor. I'll just put the wall. Right? Those are all examples of planes, but they exist in 3D. Okay. But the flat surface itself is not supposed to have thickness. It's the conceptual idea. When you draw something like a plane, you have to kind of, there's a couple ways. I mean, we could be boring and draw like a rectangle and be like, that's a plane. Okay. Um, we'll talk more about that figure later as a rectangle. But an interesting way of drawing a plane is they tried to give it some kind of 3D effect, so you can tell that it's supposed to be representing something that exists in space but has no thickness. Okay, so the way they kind of do that is they often draw a point and a line coming out of the plane, and then they do, that's supposed to be dashed. It didn't look very dashed to me. Let me fix it. Okay. And then they continue the line. So you're like, oh, it went behind there. Okay. So that's existing in the third dimension, but the item itself, this red, is a plane, right? And it is, in fact, has no thickness. And it goes on forever, but of course, I can't really draw that. I'm just giving you a snapshot. Great. So there we go. Now, this kind of spills right into the concept of angle. So an angle is formed by two rays with a common endpoint. Okay, so the rays we drew earlier. Let's go ahead and draw one. There's one ray, and here I'll go this way. So there's the other ray. All right, so here I'll call this point A. This will be B, and this will be C. All right, so the rays themselves are AB and AC, with A being the common starting point, okay? And then the angle itself is the space between the two rays, that kind of arc between the two rays. So the notation we use to represent that angle is we use this kind of little symbol like this, supposed to kind of mimic the idea of two rays, and we often put the little arc between them. And that is, we're going to use the points to indicate the angle. Okay. And that's just because we could get into complicated pictures where there could be multiple rays, multiple things, multiple angles. And so we want a way of being able to refer to them. So I refer to it based on the order, so that A happens to be in the center. So BAC would be the angle there, where A is that central point where the two rays come together. I could have also had gone the other direction and said CAB, right? Again, A is in the center, and it's kind of mapping the idea that we're going from here to here to here. Okay, so that's how we get that. And sometimes they actually will label when there's a lot of angles or points, but we'll see that later on. Okay, midpoint. Concept of midpoint, that's going to exist on a line segment, okay? So it's a point on a line segment. It has to have an end, okay? Because it's going to split the line segment into two equal pieces. So a point on a line segment that splits the segment or divides into two equal pieces. So go ahead and draw that. Wow. Okay, there we go. Endpoints A, B, and C. So C is a midpoint if the lengths of A and C, AC, line segment AC, and line segment CB are the same. Okay, so if it splits them up into two equal lengths. All right, now they spend some time kind of talking about angles, and we're going to come back to them, I believe, in chapter 11. But let's go ahead and get some vocabulary out of the way, and you might know some of this already. But angle measurements themselves. So here we're gonna spend some time talking about angles. So angles. All right. So first thing I want to talk about is measurement. Okay. So a circle. So we talk about angles in their measurements based on a circle. So a circle is divided into 360 equal parts. This gives us the US measurement for degree. And actually, if you want to look at that kind of real specifically in the book on page 625, they actually show what a degree looks like on a circle. And it's actually small. It's very small. A single degree is pretty small. All right. There is an alternative form of measurement for angles. We won't be working with that, and that's radians. But that's really more for calculus, trigonometry. Okay. We will focus on degrees. Degrees are still used in trigonometry. Okay, so let's get some terminology out of the way, or actually here, definitions, more definitions. There are a lot. Okay, so a right angle is an angle that measures 90 degrees. I think most of us know that visually. We use often a little box to represent that angle, even though my box is kind of crooked. Here, I'll do my best to draw. Yeah, that's worse. Okay, here we go. I'm gonna actually, there we go. Boop, boop. The sound effects made it work. Okay. Next would be what is called a straight angle. And as that word straight implies, we're talking about really it's an angle that looks like a straight line. So that's an angle that measures 180 degrees. So 180 degrees would be this angle right here. Okay. And then we have what's called an acute angle. This is an angle that's less than 90 degrees. So like the angle we drew earlier when we introduced that notation. And then an obtuse angle is between 90 and 180 degrees. So smaller than 180 degrees, but bigger than 90 degrees. We call that obtuse. So here, I'll draw it like this. That would be an obtuse angle. Okay, the opposite side of that, by the way, actually has a name. If the angle actually is bigger than 180 degrees, okay, we call that a reflex angle. And this is bigger than 180 degrees. Okay, so just so we're kind of clear, there is some terminology. Most of us have probably heard some of this before. Hopefully it's not brand new. But yeah, these are all names. We should know what they represent. Okay, complementary angles. And this is complementary spelt with an E. Complementary angles. So it's not angles that are nice to each other and say nice things to each other. That's with an I. Okay, these are adjacent angles. Oh, oops, actually, I should define adjacent angles. Sorry. I'm sorry, I'm making you erase. I apologize. Okay, adjacent angles. Let me start with that. Adjacent angles. Okay, so adjacent angles are angles that share a common side. So a way of saying that is they're right next to each other. Okay, so if I go to draw an angle, and then I draw another angle. So here's one angle and here's the second angle. Okay, oops. So we often try to use these like little arcs to show the angles we're referring to. And sometimes when you're trying to show two different angles, you might make them visually kind of different by using a double. Some books may do like little marks in between them. That can show that they're not equal angles. But yes, the best way though of labeling angles is to actually give them physical labels like we talked about previously. Okay. So here, let me give it some new letters this time. We'll do D, G, F, and H. Okay. So angle D, G, F, and angle F, D, H are adjacent. And they share, the side that they're sharing in common is that angle, I'm sorry, that side or ray DF. Okay. So the common side is the ray DF. Okay, so there we go. Adjacent angles. Sorry. Now that I've defined what adjacent angles are, we can do complementary angles. Now, I'm not saying you had to have seen these before. So if that kind of scared you when I said you might have seen them before and you're like, crap, I don't remember, it's okay. I'm not going to assume you have. Okay. We're going to go through what they all mean. I'm not going to make any assumptions. I do believe that most of us at some point have seen 90 degrees or right angles. So I think some things we're probably somewhat familiar with. Okay. But I'm not going to take it for granted. I'm going to go ahead and make sure to let you know what everything is. Okay. So these are adjacent angles that add up to 90 degrees. Or another way of saying is they form a right angle when they're together. Okay. Okay, so here to draw this, I'm gonna draw a right angle here. Yeah, I thought that was going to be kind of crooked, but it like froze there for a second. There we go. All right. So here's my right angle. And then here I'm going to shoot a ray out right there. Okay. And we'll call this A, B, C, D. Why not? I'll be boring again. Okay. So let's say then the angle BAC and angle CAD are complementary because together they are forming the right angle. So here's what's kind of nice. There is a nice notation we can use, to represent this. So the notation we can use. So I want to kind of start talking about the measure of the angles. So when I write the angle kind of like in this format, I'm kind of talking about the conceptual version of where it is on my picture. Okay. But it's possible that it actually has some sort of measurement. Okay. And in that case, the measure of the angle, we use this M to represent that. So the measure of angle BAC, whatever that measurement is in degrees. Wow, that looks a little weird. Sorry, let me fix that. Looks like a triangle. Okay, the measure of angle BAC plus the measure of angle CAD equals 90 degrees. So that's the mathematical way we can write it with the correct notation. Okay, so that M in front means measure. And for us, we're talking about in degree. All right. So if I happen to tell you that the measure of angle CAD was, let's say, 37 degrees, then you could find the measure of BAC. Oops. By simply taking 90 degrees and minus 37 degrees. So let's see, that'll give me 53. Doing it in my head. Pretty sure it's correct. Okay, 53 degrees. So there we go. Complementary angles. So then we also have supplementary angles. So supplementary angles are kind of similar, except this time the two adjacent angles form a straight angle. And a straight angle is something that is 180 degrees. So let's draw it. Here's my straight angle. I'll call this A, B, C, and then here, boom, there's angle D shooting off. I'm sorry, ray D shooting off. Okay. So here's our two angles. All right. All right. So the measure of angle ABD plus the measure of angle DBC equals 180 degrees. Now I want to pause for a second because I know I mentioned it earlier, but I just wanted to say it again. Okay. Especially because we just have a lot of vocabulary going on right now. I could have written this, and you don't have to write this down. This would have been the exact same thing as saying the measure of CBD plus the measure of DBA, right? Saying that it's the same exact statement is 180 degrees. Like, it doesn't matter if I switch things around, okay? It's still referring to the same two angles on my picture, okay? Just wanted to emphasize again, we can write them in the reverse order, and there's nothing wrong with that. Okay, cool. Supplementary angles, so exciting. Next is vertical angles. Vertical angles are kind of fun and actually pop up a lot more in geometry than I think people sometimes realize, which I think makes them fun. Okay. Here's what's interesting about vertical angles. They're non-adjacent. Okay. So they're non-adjacent angles that are formed by the intersection of two lines. Wow, I'm not gonna be able to fit that. Hold on. Let me shift this up again. By the intersection of two lines. Okay, so let me go ahead and draw what I mean. So here's one line. Sorry, it kind of froze there for a second. I had to give myself a second to let it catch up. Okay, there's one line. Here's another line. Great. They're crossing. They're intersecting. Okay. So let's call this original line A, B, C, and then we'll give this lines D and E. Okay, so the vertical angles are not adjacent. Okay. That would mean that they don't touch. So this angle here and this angle here, those are vertical angles. So angle DBA and angle CBE, those are the vertical angles. There is another set of vertical angles sitting here, though. I hope we see that. It's the obtuse ones. This one here and this one here. Okay. So for that one, we would call that angles D, and I'm sorry, I kind of drew through that B there. So DBC and angles ABE. So those two angles are also vertical angles. I do want to mention, though, that there are some supplementary angles sitting here as well. So since we just talked about it, let's just take a second and label them. Wow, I'm going to try to do this correctly. Supplementary angles. And I would encourage you to take a second, maybe pause the video and label it. There's going to be 4 sets of supplementary angles. Okay. Here, I'll kind of underline this so that we know we're talking about categories here. Okay, so the first set, I'm going to go ahead and do this angle and this angle. Okay, so those two that form this line right there. Okay, so that's going to be angle ABD and angle CBD. Okay. And then the opposite side of that, so from here to here, those two angles are also supplementary. So that would be angle ABE and angle CBE. Oops. CBE. Okay. And then there's the other side, other line. So these two right here are also forming a straight line. So that would be angles DBC and angles or angle CBE. Okay. And then lastly would be this line right there. So that is angles DBA and angle ABE. And there you go. Supplementary angles. All right. The last thing I want to refer to is they kind of give, because we're talking about angles, and they are going to revisit this, okay? But they do kind of take a moment, pause, and talk about then perpendicular and parallel lines. And the reason is perpendicular and parallel lines form quite a few angles. Before we do that, that's a weird version of an A there. Parallel. Wow, that's supposed to be an E. Sorry, let me do that again. Parallel. There we go. Parallel lines. Okay, so perpendicular lines are lines. Sorry. That intersect wow, it's going really slow. I'm sorry. It's because I'm drawing so many pictures that intersect at a right angle. Okay. And the minute one of the angles is a right angle, all of the angles are right angles, right? Like all of these now are right angles because that's how circles work, because it all together it would be 360 degrees. And if one of them is 90 degrees, they all end up being 90 degrees. Okay. Okay. So that's our perpendicular lines. I do want to give some notation here. So if I call this the line L and the line M, the notation we can use is it's kind of like an upside down capital T. That's the notation we can use to represent perpendicular. Okay. That says L is perpendicular to M. And we know, especially once we start switching into cursive L's, all right, that we're talking about lines. Parallel are when two lines never intersect. Which means in terms of concepts, they have the same slope. Wow, that's a terribly drawn. I'm sorry, my computer is very harsh with me when I try to draw diagonals. They always come out looking squiggly. Oh, well, all right, pretend those are straight. This is L, this is M. They never cross, they're the same slope. And I would use this notation. It looks like two double lines like that to represent and say that they are parallel. So L is parallel to M. Those are supposed to be the same height, but you know, I'm a human and not a robot. Great. Okay, now here's where angles come into play. Now, of course, with perpendicular lines, there's obviously the right angle, but more over or more detailed than that is possibly when we have parallel lines cut by what's called a transversal. Okay, so let's say I told you L is parallel to M. Okay, I'm giving you this important statement. Wow, let me give myself more space than this. I'm sorry. Okay, so there's two parallel lines. We'll call this one L, this one M. And then I mentioned this word transversal. Okay, I'll call that line N. And they say N is a transversal line. All that means is that it crosses both of them. It's a line that cuts through both of them. That's it. That's all it means. Okay. So crosses both lines. So exciting. Okay, but here's what's really exciting. There are angles sitting here. Actually, there's a bunch of angles sitting here, but we're going to focus in on the inside of the two parallel lines. So we have some angles in here, okay? Like this angle right here, if it'll ever draw it. There we go. There's that angle right here. I'll call it angle 1. And then this one I'll call angle 2, angle 3, and angle 4. Okay. Those are lines that are inside the two parallel lines, okay? We call these angles interior angles, okay? All of those are interior, but they make a point in this section, okay? So here, let me label that interior angles. That's an O. I'm so sorry. It really is just being a little bit slow. Interior angles are angles 1, 2, 3, and 4 on my picture. I could do angles on the outside, right? These angles out here. Boop, 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 boop. I'm not going to do that right now. Okay, they're not focused on those. Those are interior angles. And then we have what's called alternate interior angles. Shift my screen over here. You're going to let me? I know you want to. There we go. Alternate interior angles. That means they alternate on the sides of the transversal. Okay, so of the interior angles, the ones that are alternate interior angles are angles 1 and angle 3 because they're on opposite sides of the transversal. They're on alternate sides of the transversal and they're interior. Okay, another set of alternate interior angles would be 2 and 4. Those are also alternate interior angles. And then we'll revisit this later and we're going to look at the exterior angles and all of that too. But they just wanted to go ahead and give this terminology since we started talking about angles. We talked about parallel lines. Might as well go ahead and throw that in with this. And that is the start of our geometry section.